Well, good afternoon and welcome to another episode on Stuart's Classic Bikes and Cars. Well, we've had some post this morning, or delivery. So in the mail this morning for the Project Racer, we've had this arrive. So, what we've got, a new clip-on bars. So these are the new clip-on bars I'll be using. I've got the 30mm to go with to match my HD3 stanchions. So these are the two clip-on bars I'll be using. So we'll just put them out the way for a minute because we're not messing about with them today. Well, that's a job. Once we get the forks in, we can get the clip-on bars sorted out and the new quick action throttle organised. So that's a little job for another day. Maybe another wet, rainy day here in the Philippines, but let's see what we're doing today. Right, what I'm doing today, and I've lost my pen already. How can you do that? Just a second while I find my pen. Dear me, I'd lose my head if it was loose. There we go. I think it's an age thing. As you get older, you put things down, you've no idea what you've done with them. Right, here we go. Glasses, pen. Right. What I did notice, this is a cylinder head, which we're going to alter for our racer here. It measures approximately the vernier, it's maybe easier. It's about 62 to the outside of the squish band. And the inside 40. So let's just make it easy and say 60 for the OD of the squish and 40. So the squish band is approximately 10mm wide. But the big problem I've got is, if you look at this engine, when we measured the squish on here, if you look at the top of the piston, I've marked on the piston 10mm, which is the inside of the squish band, and that mark there is 5mm, which is halfway up the squish. Now I do know that when this piston, I've got my timing disc on, so this is at top dead centre. I do know that when this is at top dead centre, the centre of that piston dome is approximately 3mm above the deck of this cylinder head, where the cylinder head fits. So the middle's 3mm high, and the outside, right next to the outside here, right the outside of the piston, is about 1.2. Now I'm looking for 0.8 between over the full width, over the full 10mm. I want this gap to be 0.8, but it isn't, because the dome on this piston is a different shape to this squish area. So what I'm going to do now is take a couple of basic measurements to see if I can fathom out what I'm going to do. Now I could weld this up, weld the squish area up and remachine it. The only problem I've got is it might warp the cylinder head. So let's think about this before we start doing anything. But the other thing is, this won't be the piston I'm using in the race engine. I've got a forged piston coming, and it's unfinished dome, so the dome's too big on the new piston. So I'll be able to machine the piston to the same shape as this squish area. So let me just measure the squish and see where we are by measurement and see what the difference is between this dome on the top of the piston and this squish here. Because we know that the outside is about 1.2 millimeter. Now this rule is 25 millimeter thick. 25 mm thick. So all I'm going to do, find a different pen. I'm just going to quickly mark on the cylinder head halfway between the squish area. Just roughly, so I can get an idea of the angle. So what I'm going to do, I'm going to put a straight edge over the cylinder head, and I'm going to measure down with my vernier to the inside of the squish and see where we are. Now I know the outside's 0, because the outside of it, the outside is flush with the top of the mating surface of the cylinder head. So let's just measure the inside. So we'll first zero, make sure we know what we're doing here. We'll first zero the vernier. I'll put my straight edge over. Just hold it steady. And I'm going to measure down to the inside of the squish. Try that again. It's approximately 29 millimeter from the top of this rule to the bottom of the inside of the squish. But let's not forget, this rule is 25 millimeter. So if we take the two apart, if we take 25 from 29, we'll get the distance under. So 25 from 29 is 4 millimeter. So we now know that the inside, I'll write this down so I don't forget it, the inside measurement to squish is 4 millimeter. So that's 4 millimeter over a width of 10 millimeter. So it goes down 4 milli and the squish area is 10 milli wide. So squish area is 10 millimeters wide. So let's just check halfway between, like 5 millimeter, along halfway to the squish, and just see what measurement we've got. Let's make sure we zero again. 26.7. So 25 of 26.7 is 1.7. So five mm along squish, axially along squish, is just measure that again, just make sure. Just check that. Trying to make sure that the rule's 0 millimeters. So yeah, 26.8, so that's 1.8. $1.8 millimeters. So what I'm going to do, I'm going to draw this out at home. I'm going to draw this angle out, and I'm going to draw the angle of the piston out, and then I'm going to see what the difference is. Because what I want to do, I need to make the angle on this squish the same angle as the piston top. So when we have a 0.8 clearance at the outside of the squish, I have a 0.8 clearance on the inside. Because the squish clearance needs to be the same all the way around the squish area. So 0.8 to 1 millimeter all the way around from the outside to the inside of the 10 millimeter squish. Right, so let's just measure this piston now. So on top of the piston, I've marked 10 millimeter and 5 millimeter. But let's just see what the mosquitoes are all over the place. Let me just put my fan on to discourage these mosquito armors. Right. Piston checking, it's still at top dead centre. And we know that the centre of the piston above it, from the centre to the top of the landing for the cylinder head mating face is 3 millimeter. So, let's see where we are now. I'll hold that on there. So the inside of this piston measures 26.6 at top dead centre. So if I take 25 off it, 1.6. So 10 millimeters in where the outside of the squish is, I've got 1.6. So let me write that down. Somebody stole it. Here we are. I thought somebody had crept in and crept back out again and taken me pen. So, let's do a little drawing of the piston top. So the centre of the piston is 3 mm above. The inside of the squish at 10 millimeter width, which is the inside most size of the squish area, the full width, is 1.6 mm. So you can see the problem. Because the inside measures of squish is 4 millimeter and 1.6 there. So the squish is far too big. So if I take 1.6 from 4 millimeter, what I've got is the clearance here on the inside of the squish by measurement, because the piston at this area measures 1.6 and this head measures 4 milli to there. So if I take 1.6 from 4 millimeter, I've got 2.4. So the squish clearance to the inside of the squish is 2.4 millimeter. 2.4. And I only want, so it's at least 1.4 to 1.6 too big, which means that this angle is wrong compared to this piston. But it won't matter, because I'm going to alter the top of this piston. So now I know where we are. I know where the piston is, and I know what the size is. So I've got the piston coming, and when I get it here, I'll work out and I'll make a drawing of the piston and what size I want it to be. And I'll take it to a local machine shop and get it machined. Well, thanks for watching, and that's all I'm doing on this engine at the moment today. But keep watching, keep interested, please subscribe, and I'll see you again tomorrow. Take care, bye-bye.